Hi there, I'm Adedo Insola, and if you're interested in the first part of the series where I did a quick dive about how we started from counting to how we got to graph databases and beyond, you can take a look at the description below look at the video, and you can also view this project on DevPost. The link is also attached in the description. So let's do a quick walkthrough of the project. So I rank spice. So this notebook documents the development and exploration of a patient network analysis tool. The goal is to provide a user-friendly interface for querying and visualizing relationships between patients and their conditions. And here we have the graph of the Synthea data set that we use. So since the Synthea data is already loaded in ArgoDB, so all we just had to do was load it. It's already stored in ArgoDB. We'll just had to load it. So install dependencies. Okay. And a very important part of it is the NetworkX and QGraph integration. So where we just set the environment variable graph autoconfig to true. So we don't really need to change the underlying code of our code. Once we import the NetworkX as NX and NX.betweenness centrality, and it's good to go to calculate. It's quite powerful. And here we define the particular tool, which is just based for a custom to translate natural language to AQL and then back. And then this is a deep dive in which we notice that trying to build queries with location adds a significant hurdles. So we had to generate synthetic location for a particular query, which we have one here, where we ask the connected patients in the network in New York, and we're able to generate these nodes and graph, which are all just generated location. Even some of the conditions here were generated, just to show like what could happen if the system had those locations, and if they were not empty, those locations were not empty and they were fully populated, we could build a graph and see the connections of a patient network in New York. Let's scroll down. Yeah, so we have condition centrality analysis tool, which is just separate, and so allows us to analyze the centrality of different medical conditions within a patient network. The centrality we calculated before for the patient that involved location, that was generated on its own, and it was an hybrid of both the AQL and NetworkX. But this particular one here, although we are going to extract location, but if we actually were to use a location together with the query, it won't use us anything. So this particular condition centrality is based on what we already have in the graph, and based on what we already have in the graph. Then medication review, condition coherence analysis. So this particular section analyzes the co-occurrence of medical conditions in patients who have undergone medication reviews. So it's just to see the interaction between all of them. Yeah, so we define the tool and the visualization. We also have the smart router as well. Yeah, thank you. So we could query the system. are the most common conditions in the database. So the most common conditions are medication review, stress, full-time employment, part-time employment, and you can see it's also generates and or also added the visualization for it, and can also prompt. This is just the basic simple query. And we could also ask calculate the centrality. Calculate the centrality of different conditions in the patient network. So it reveals a striking concentration of centrality around medication review due. This condition dominate both the top central conditions and co-occurrence lists. We also have the visualization, and we can see the measuration review due is quite high, then followed by Otis media. We also have a pie chart here showing active conditions and inactive conditions. And you can see the top 5 conditions by patient count. So by patient count, we have a lot of patients that are being diagnosed with hypertension. And it's based on what we have in the database, the Synthea data set. And we ask for patients with medication review condition, what other conditions are they likely to have? This is a combination of AQL and the network X. And we also have visualization in there. Data reviews and medication review dues is overwhelming dominant, which we've been noting in virtually all the visualization we've been seeing, and even the results. And here we have the nodes, and we have the condition relationship network. So not in labor force, part-time employment, social contact, full-time employment. So the medication review condition is just right in between, and you can see all the connections with other conditions. So healthcare providers managing patients flagged for medication review should adopt a holistic approach. While the data set highlights the need for the review itself, it is crucial to delve deeper into the individual patient circumstances. Consider factors such as their social support network, employment status, stress levels, and any potential underlying mental health issues. Tailor medication regimens and review processes to address these individual needs. For instance, patients experiencing high stress level may benefit from additional counseling or support service to improve medication adherence. So also it's quite a strong analysis of the data we have, the Synthea data we have in the graph data set powered by Good evening.